Well, hello students. I hope you all are doing well. Today we are going to discuss one of the very important theorem for board exams. As you can see in the screen, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. We all know this theorem by a name, that is Thales Theorem, which is very famous, and also we call it Basic Proportionality Theorem, right? So here you can see a figure naming triangle ABC, and in the purple color you might be able to see a line that is parallel to BC, right? A line DE parallel to BC. These two lines are parallel. So we are given a triangle ABC in which DE is parallel to BC. So we also need to see what we have to prove. We have to prove that the two sides are divided in the same ratio. That means the ratio AD upon DB will be equal to AE upon EC. So we'll write it to prove. So as you can see, we have written to prove AD upon DB is equal to AE upon EC. So for proving this, we need a construction to be done. So what is the construction? We will join D to C and B to E, and a perpendicular will be drawn from D to M. As you can see, D to M perpendicular over AC, and E to N perpendicular upon AB. So these two constructions are required, and also we'll write it here. Next we move to the proof part. So we know that, what do we know? That area of a triangle is equal to half into base into height. Here the point to be noted is base and height. Height stands for the perpendicular height from the base. So we'll be careful while taking the height. We will see that we'll use the triangle, and in the triangle we'll choose base carefully, and accordingly we will choose perpendicular height, right? So here you have to keep in mind, while taking the triangle, you will see what we have to prove. We have to prove AD upon DB. So accordingly we will take triangle ADE and DBE. You will see that AD and DB is the same thing, right? And we have added here ADE and DBE. So where is ADE? This part is ADE, and in the bottom line this part is DBE. These two triangles are taken. Okay, so we use the formula, area of triangles formula, which we have written above. So area of ADE will be, so as I told you, we will choose the base and height carefully, right? So here for the triangle ADE, we'll take the base AD, and for triangle DB we'll take the base DB. You will notice this AD and DB are the same thing which is over here, which is given here in to prove section, AD upon DB. So it is same AD upon DB. And while taking the height, while choosing the height, we will be careful, right? So we'll take height upon AD. You will see here it is En, and dB also, by extending this dB side, you will see, as you can see my this line, if you will extend it, the height will be same En. So this has one advantage, that while getting the final result, this 1 by 2 gets cancelled, and this En and En gets cancelled, so we are left with AD upon dB, and this is equation number 1. Okay, so in the same way we may write what? Area of triangle AED. So you see here, AED is this triangle, AED, this triangle, and ECD. So here we need some a little bit of correction. So this is EC and D, these two triangle, one triangle is above and one triangle is in the bottom. So you will note that this AED, or in the previous one we have written ADE, are the same thing. So we are taking here AED and ECD. So you will see that AED and ECD in two proof section, the same name are being taken. So in exam, while you are memorizing this theorem, it will be helpful for you. Just you need to add here D and here also D. So again, choosing the base carefully, we will write here base AE, and height for AE, this AE, the height will be DM. Here the base will be EC, and again the height will be same DM. So this 1 by 2 gets cancelled out, DM also gets cancelled out. So it becomes equal to AE upon EC. This is second equation. Let's say this is second equation. Now here one thing you need to remind from one of the theorem you have studied in class 9, that says that the areas of two triangles on the same base and between the same parallel lines are equal in area. So you'll write, we know that triangles between the same parallel lines and on the same base are equal in area. So this DBE and ECD are equal in area using this theorem, and the above one, AD and AED, both are same thing only. So we suppose this one is the third equation. So using equation 1, 2 and 3, we get, what do we get? We get AD upon DB is equal to AE upon EC. So that's all. It proves our theorem as well. So I hope learners, you might have understood well Thales theorem and proof of it, and I am hoping that this will be helpful for you in upcoming exams. Thank you. That's all for today.